Good morning, Grade 8s, and welcome to the WorksheetCloud Grade 8 Natural Sciences lesson. If you have a question during the lesson, please send an email with your question to grade8@worksheetcloud.com and we'll get back to you with the answers as soon as we can. I would like you to think about what I've written here. This message for you today. Your learning and your education is the key that will unlock your door to success and freedom. And I am really, really proud that you have taken ownership and control of your learning. And I know it might not seem like it, and it's difficult to get through these days without being at school, but you definitely are unlocking doors. You definitely are learning how to be a successful individual. You're learning how to make your education a success. You are in charge and in control of your learning, and that is going to give you certain degrees of freedom. So I am really, really proud of how you've taken control of your learning. Keep it up. I am here for you with these lessons, and if there's any way or any questions that you have, please remember that you can email us. So I am Mrs. Ernston, the WorksheetCloud Grade 8 Natural Sciences teacher, and I love presenting these lessons for you, and I hope that you are learning lots with me each day. I do think it is important for you to take notes and keep a record of the lessons that you do, and there are lots of things in class that we discuss and go through, and there are lots of little things I ask you to jot down and write down. So instead of just sitting back and listening, I think it is important that you keep a record. It will also help when you get back to school for you to show your teacher what you have done. So what we're covering in today's lesson is we are going to go over the definition for density. We're going to look at a bit of maths and calculations today. So mathematical relationships between density, mass, and volume. So the equation we're going to focus on is density equals mass divided by volume. We are going to see how to determine an unknown substance using either values we've been given, mass or volume or density. That density is a property of matter, and we will look at just introducing some graphing skills. So I would like you to engage in today's lesson, and this is an interesting thinking activity for you to do. I am going to tell you that the answer is density, and I want to see if you can write out 5 questions whereby the answer for those 5 questions is density. So pause the video now and spend about 1 to 2 minutes thinking up 5 questions where the answer is density. So the other thing that I'd like us to engage in is graphing skills. And I just want to recap everything that you need to remember when drawing a graph or looking at a graph and going through a graph. So the first thing you need to remember is your graph always needs to have a heading. And in this case, we've got our graph is about volume versus mass of silver. Then you need to remember that you have got a vertical scale and that the scale is actually correct according to a type of number line. So you will see that there is a mathematical scale on the vertical axis. You also need to check that you have a horizontal axis and that scale is correct. So you'll notice that the vertical and horizontal axes don't have to have the same scale, but it needs to be numerically correct. Then it does differ per subject, But in science, it is good to start your graph at 0. So the origin must be 0, and you must have this clearly filled in. Then both your vertical and your horizontal axis need a title and units. So it's very important that you don't forget the units. Then you're going to have to plot some points. And just remember that those are small, but they're clearly and neatly done. And in this scenario, they're little diamond shapes, but in science, we generally like you to mark it with a very small, neat S. I know this differs from teacher to teacher and subject to subject. So if you don't do a nice small X, some teachers like a small little dot and a circle around it. So just check with your teachers how they would like you to plot these points. But there is a mark for plotting points. And in line with this, there will be a mark for doing a line of best fit, which is, it's not always necessarily a dot to dot connecting the lines. This also depends per subject. So just check again with your teacher what line they would like you to draw. And then often we only want you to plot the points that you are given. So not every graph necessarily starts at 0 or goes through the origin. So it's really important that you just plot what you have. And then please remember your graphs must be neat. All teachers have different rules on whether they are in ink or whether they're in pencil, and what must be in pencil and what must be in ink. And just remember, it's often a good idea just to do the graph in pencil first. So if you make any mistakes along the way, you're able to erase those mistakes. And then you can always go back later and go over in ink. But I know that there are a lot of teachers, we don't like highlighters and things like that. So just double check, your graph must be neat, and check that you have done the correct graph. So I have picked this graph because there is a theme that continues into this lesson. And that theme is looking at mass and volume and the relationship between mass and volume and how this links up with density. So silver, which we find on the periodic table, is represented by the symbols Ag, capital A, lowercase g. The density for that is 10,49 grams per centimeters cubed. I know that the graph here shows mils and here shows centimeters cubed. Just as a reminder, 1 centimeter cubed is the same as 1 milliliter. So how did we come to the silver being 10.4? Well, if we have a look at this graph here, and we have a look at the plot of this point, this plot over there is probably 31. So I know it is quite tricky to read off this graph, but this point over here is definitely a volume of 3 mils or 3 centimeters cubed, and the value here is probably about 31. So if you've got to read off about 31.4 or 31 and you divide that by 3, you will find you get a number of 10.49. And as you move through that, if you pick each of these plotting points and you divide mass by volume, mass by volume, mass by volume, mass by volume, you will find that you get the same value, which is 10.49. And that means that this gradient of this line is density. So according to this graph, it doesn't matter what mass you have, so long as there's a correct ratio and proportion between mass and volume, we will get density. So in our activity today, we are going to calculate the density of 3 mystery substances. So I've given you 3 cubes, and we are going to work out what is the density of these 3 cubes. So the one thing I'd like you to remember is the equation density equals mass over volume. So the first thing we need to do with our mystery blocks is we're going to number them, block 1, 2, and 3. So the large block is block 1, the medium-sized block is block 2, and the smaller block is block 3. Now, when we have to calculate density, we need to calculate the volume and we need to calculate the mass. So in order to calculate the volume of this regular shaped object, we are going to use the equation volume equals length times width times height. So here we have our cube and its length times width times height. So generally, we would then record those measurements. So as an example, 1 centimeter by 1 centimeter by 1 centimeter is going to give us 1 centimeter cubed. And just a reminder, I mentioned it earlier, but 1 centimeter cubed is the same as 1 mil. So I have gone and I've measured the length and the breadth and the height of 3 mystery blocks. So I measured the height, and I measured the length, and I measured the width of mystery block 1, and it turned out to be 100 centimeters cubed. Then I went to block 2 and I measured the width, and I measured the height, and I measured the length, and I got a volume of 50. And then I went to the smaller block and I measured the length, and I measured the height, and I measured the width, and I got a value of 25. So now we have the volumes of our mystery blocks. And now we need to calculate the mass of our mystery blocks. So you can do this in the lab or back at school using a triple beam balance or an electronic scale. So I got the electronic scale out and I measured the mass of the 3 blocks. The largest block had a mass of 270 grams. The second block had a mass of 135 grams, and the smallest block had a mass of 67.5 grams. So here we have recorded the values in the table. And now, I want to see what would happen if we had to take these values and plot them on a graph. I just want to see, out of interest's sake, what we would get. So what landed up happening is when I plotted those values of mass and volume, I got a straight line. So what does that tell you? So we know that the density of an object is its mass divided by its volume. And we know that this relationship is linear. So what does that tell you about each of those 3 mystery blocks? We'll get to the answer a little bit later this lesson. And just a reminder of everything we need to remember about graphing skills. So I know that this graph is missing a couple of things. So pause the screen for a moment and go over everything that a graph needs to have. So if we think about it, it needs a heading. So it's a line of best fit of mass versus volume for 3 unknown substances or 3 unknown blocks. I have got a scale on the vertical and horizontal axes, and I've got a title for the vertical axis is mass, and a title for the horizontal axis is volume, but it's missing something. Do you know what that is? Yes, it's the units. The units I used for mass were grams, and the units I used for volume were centimeters cubed. So you need to go and add that in. then yes, this graph was done on a computer, but you need to remember that if you hand do a graph, it would have been nice and neat using your pencil. And the other thing that's missing is the actual dots showing the exact points that are plotted. So just bear that in mind when we have a look at graphing skills. So let's do a little bit more exploration and see if our thinking on the fact that these blocks are all the same substance, because that line for density was linear. So for our large block, we're going to take the values from our table. So density equals mass divided by volume. So that's 207 grams divided by 100 centimeters cubed, which gives us a density of 2.7 grams per centimeter cubed. Okay, you can pause this and copy the calculation down if you need to. Okay, so there's our large block, and we calculated that it was 2.7 grams per centimeter cubed. Let's go to our medium-sized block. So the equation to calculate density is density equals mass divided by volume. So in the case of our middle-sized block, the mass is 135 grams divided by 50 centimeters cubed. And if we calculate that, the density is 2.7 grams per centimeter cubed. So what do you notice? That the density for the middle block is exactly the same as the density for our larger block. And let's calculate the density for our smallest block. So density equals mass divided by volume. So the mass of the smallest block we measured was 6.67,5 grams, and the volume was 25 centimeters. So we divide by 25 centimeters cubed. Therefore, our density for our smallest block is 2.7 grams per centimeter cubed. So this matches up with our graphical representation of our mass versus volume. So you can pause the video and copy this calculation down. So here we now have a table showing the mass, volume, and density of the different blocks. So we have mystery block 1, 2, and 3. We've got the volumes, we've got the mass, we've filled in the density. So what do you notice about the density of each of the mystery blocks? Well, we notice that the density is the same. So just remember to calculate density, it's mass divided by volume. And if we go and have a look at density tables, or we just Google what has a density of 2.7, we will find that aluminium has a density of 2.7 grams per centimeter cubed. So can you write a conclusion for this experiment based on the results? So you can use the table, or you can use the graph to get your main points and main findings. So we can conclude that the 3 blocks are probably made out of the same substance, that the substance is aluminium, that has a density of 2.7 grams per centimeter cubed. And we can get this information from the fact that when we plot mass versus volume on a graph, we get a straight line, and this linear relationship shows that the blocks have got the same density. And the other thing is when we use the calculations for mass divided by volume for each of the blocks, or when we calculate the density for each of the blocks, we come up with the same number. So we could probably conclude that these blocks are all from the same substance. So just to explain what we have done, each pure substance has its own density value. And if you need a revision of pure substances, you can go back to one of our earlier lessons on atoms, elements, compounds, and mixtures. So a pure substance refers to elements or compounds. So anything on the periodic table will have a density value. So for example, copper, which we represent with the symbol Cu, capital C, lowercase u, has a density of 8.92 grams per centimeter cubed. This value is constant. So long as the ratio between mass and volume stays the same, whatever size or shape or amount of copper we have, it will always have the same density. So whether you are dealing with copper wires, or whether you are looking at copper coins or copper pennies, or whether you've got a block of copper, that value, when you work out the volume and when you work out the mass, will always give you the same number for density. So irrespective of how much substance we have. So that means that density can be used to identify a substance, particularly if it is a pure substance. So this is just an example of the variety of density tables that are available to you. So yes, in this case, the densities have been written as grams per milliliter. If you just go back to yesterday's lesson, we go over all the different ways that we can represent mass and we can represent volume. But here is just one example of a density table. And as we progress through the lessons, you will find this table under our worksheet sections, and it just gives you some of the density values for some of the substances that we'll come across in our lessons. So you don't need to learn these values, you don't need to know them off by heart. If you do need to know what the density of a substance is to work out a calculation, it will be given to you. So you do not have to learn any of these numbers off by heart. I've just put them here for you as a reference. So just to elaborate as we reach the end of our lesson, this is leading on to tomorrow's lesson, whereby density tells us about how tightly packed a material is. So density is a measure of how much mass fits into a given volume. So A, we have a solid, B, we have a liquid, and C, we have a gas. So the solid is going to have a higher density because it has a greater mass. The gas is going to have the lowest density because it has the smallest mass, but within the same volume. So you will notice the volume of the cubes we have kept the same. But how many particles we find in that volume differs. So if we just remind ourselves that the solid has the highest density because it has the greatest mass, and the gas has the lowest density because it has the smallest volume, how do we go about explaining why ice floats on water? Because ice is a solid and water is a liquid, and we would expect ice to have a greater density than the liquid. So if you want to find out the answer for this, you need to listen to tomorrow's lesson. So why does ice float on water? And I'll be telling you tomorrow. So just to check that you understand what we did this lesson, let's do a quick evaluation. So I have given you a block of material, and I have filled in the values for you. So here is our length is 5 centimeters. Our width is 3 centimeters, and our height is 2 centimeters. and I've told you that this block has got a mass of 270 grams. And I need you to calculate the density of this block. So remember, density equals mass divided by volume. So mass you have been given, it's 207 grams. And volume, you'll need to calculate. The volume of a regular substance is length times width times height. So pause the screen. Okay, so here we have a block of material measures. So volume equals length times width times height, which is 5 centimeters by 3 centimeters by 2 centimeters. So volume equals 30 centimeters cubed. So what is the density of the block? So density equals mass divided by volume. The mass we were given, which was 270 grams. The volume we calculated was 30 centimeters cubed. So density equals 9 grams per centimeters cubed. Easy, hey? So I'm sure you've done absolutely brilliantly this lesson. And you are confident about this section. If you are a little bit unsure, please go back to our previous lesson and recap any terms and definitions we covered there. And tomorrow, I look forward to teaching you about density and how that links with the phases of matter and why does ice float on water. So what have you learned today? So we go back to our beginning question. If the answer is density, write out 5 questions. So what I would like you to do now is, why don't you choose a word to be the answer? Okay, so here I've put XXX, but why don't you pick a word and it will be a word that we have covered somewhere in today's lesson, and why don't you write out 5 questions that link up to this word where your word that you've chosen would be the answer. So it's quite tricky to do. It definitely does require some thinking, but it is really good to get your brain working and to get you thinking out the box a little bit. So please remember that if you've had any questions through today's lesson, you can email your questions to grade8@worksheetcloud.com. Thanks for watching, grade 8s. I've really enjoyed teaching you today, and we'd like to thank WorksheetCloud who brought this lesson to you. So thanks very, very much. Goodbye, grade 8s.